All right, and we're live. Welcome all to the special edition, gaming edition of Change Notice. We're going to wait a few minutes for everyone to virtually file in here, joined here by Chris and Taylor.
How's it going?
And while we're waiting, a few housekeeping items. Number one, please introduce yourself, bottom right. Make sure the little blue box, you change that to send to everyone, so you're not just pinging the host directly. And would love to hear from you guys. Introduce yourself, where you're from, and what was the first gaming console that you owned? Today's focus is on gaming, since we're doing the Switch. So let's kick it off from our side. Maybe Taylor, what was your first gaming console?
I have very fond memories of the original Nintendo Entertainment System, or NES, as some people call it. My parents, well, I grew up in the 90s, and so my parents were like sort of into gaming as I was being born. And so when I was really little, my mom would help me beat Super Mario Brothers 3, because that was like, those are my first console memories, was sitting with the NES in front of the big tube TV trying to beat Mario.
I love the family involvement.
Yeah.
What about you, Chris?
Yeah, similar to Taylor. I mean, I think I was never lucky enough to have my own, but I always coveted ones from my cousins or my other family. And so I think once they upgraded to like Super NES or Sega, then I got the hand-me-down NES.
That
so
was exactly my situation too.
Yeah. Yeah, you mentioned it in the 90s. So yeah, so I had that. But the first one I purchased was actually the Nintendo Switch. So I got one of the original ones when it came out in, I think, 2017. And I spent way too many hours playing Breath of the Wild. How about you, Tobias?
Awesome. Well, we can dedicate this teardown to your first console. So mine is similar setup. I had a lot of friends that I coveted their N64, their Super Nintendo, played it, but the first one that I owned was actually the Sega Dreamcast.
Nice.
And I had a very good memory of the Sega Dreamcast. I remember the controllers were ahead of their time, just the shape of the controller. And the one thing that really stuck with me that was unique, they had this little cartridge which inserted into the controller. It served as a memory cartridge, but it also had a small little display and a little bit of computing power. And the one game that I remember, it was the Sonic game at the time. You could take out this tiny little cartridge, and it was a standalone device. And you had pets that followed you around on this small little device. You could feed them. It was almost like what was the little digipet, the Tamagotchi that you could carry around in your pocket. And I just thought that was way ahead of its time. Both the controller design as well as the graphics and the little module that got removed from the controller.
That's
so fun
so
memories
cool.
there. Yeah. All right. Welcome everyone to Change Notice. As you guys are filing in, please post down in the lower right-hand corner. Make sure you flip that you're posting to everyone. Introduce yourself and tell us what your first gaming console that you owned. First gaming console. That's the theme for today. Let's go ahead and get started here. So welcome everyone to this week's special edition of Change Notice. Today we're tearing down the Nintendo Switch. So welcome to all the newcomers, and also welcome back to our regulars. For the newcomers, the goal here is we're building a community for knowledge sharing, support, continuous improvement. And we often have our CEO, Anna, hosting with some special guests, but this week's special Unsnapped edition, hosted by myself, colleague Chris Lee, as well as Taylor from iFixit. And few reminders, few housekeeping before we kick this off. Number one, if you do have to duck out early, please fill out the survey. That gives us guidance on what to tear down next. So fill that out, let us know what you want to see. And number 2, we have an exciting event coming up. Build Better, March 3rd. This is a half-day virtual event, free to sign up. We're bringing together manufacturing and operations leaders. We're going to discuss best practices, trends in the industry. This is our big annual event. You don't want to miss it. So sign up to reserve your spot now. We'll post the link in the chat here, and would love to see. Actually, here's an ask for the audience. When you sign up, there's a form about what you want to see during this event on March 3rd. And if we get enough requests for a live teardown, I'm throwing this out here now, not knowing if we can do this for sure, but if we get enough requests from you guys to do a live teardown of a specific device, we'll make it happen. So make sure you fill out that form and say, we want to see a teardown of X, and then we'll do that live on the big stage. So with that, let's kick off some intros from our side. Let's start with Chris.
Yeah, my name is Chris. I'm a mechanical engineer. Was working at Amazon on the Kindle for a long time, and then did some a medtech startup. And most recently, I've just joined an ag tech startup. We're building electric autonomous tractors. So that company's called Agtonomy.
All right, and Taylor, you want to say hi?
Yeah, hi, I'm Taylor. I work at iFixit as a technical writer and teardown engineer. I've been at iFixit for 3 years, and before that I was going to college to study technical writing. So that's sort of my vein. That's my lifeline there.
All right, awesome. Thanks so much for joining us today, Taylor. And thank you for all those posting some memories of your gaming consoles too. I see Edward, welcome. We've got Sega Genesis, we've got Game Boy, Atari, nice, PC, good variety of gaming systems to start. So I'm Tobias. My background's in mechanical engineering and product design. Spent about 6 years back at Apple working on iPhones, Apple Watch, health technologies, and displays. And excited to dive inside the Switch today to see what we're looking at. So, agenda for this session here. We always like to say the best way to really understand a device is to take it apart and look what's inside. And maybe before we dive inside, Chris, why did we pick the Switch today? Why is this what we're tearing down?
Yeah, I mean, I think when we originally pitched this idea, the Switch was sold out everywhere from the holidays. So it was a really big year for the gaming console. So both the PS5, the Switch, and I think the Xbox have all been selling like hotcakes. So we wanted to see what all the hype was about. They also recently released this OLED version, so I think that came out last year. And I think we wanted to see what was different about this one. Also, I just saw that they released the sales numbers of the Switch, and they just recently passed 100 million Switches sold over the lifetime, which is incredible for them. So so that was it. Also, our PS5 controller, the last time we did, but I think that was one of our first change notice on Snap, was super popular. A lot of gamers out there, so we wanted to bring that back. And more recently, there's been a lot of news out there about big companies buying other big companies in the gaming world. So if you've heard anything about Activision being bought by Microsoft or Bungie being bought by Sony, it kind of all ties in together here for our gaming edition of Change Notice on Snap. I know iFixit did a teardown recently when this was first released. And so Taylor, we wanted to ask you maybe what were some of your takeaways, maybe compare and contrast, and what did you learn, and what were some things that you wanted that you still had some open questions about?
Yeah. So, for those of you who don't know, at iFixit, we take things apart to try and understand how repairable they are and then communicate that to the world so that you can make an informed purchase. So, what we were looking for in this new Switch was mostly repairability and sort of how it's put together and how easy it is to take apart and repair. And the original Switch was actually pretty decent when it came to repairability. A lot of modular components and especially the Joy-Cons have joystick assemblies that are really easy to swap out, which came in handy during the big Joy-Con debacle where Nintendo was sort of under a lot of pressure and Joy-Cons were failing and lawsuits were happening left and right. So excited to look at that. But this new OLED model was interesting for us because OLED panels are typically more fragile and like a little more complicated to assemble. So we were concerned that the display was going to be a lot more difficult to replace. And small spoiler here, they actually did a pretty good job with the design, and I'm excited to get into it with you guys. But yeah, it's a really interesting console. I'm excited to jump into it.
All right, let's get into it. A quick sneak peek here before Chris dives into it. We've got the X-ray of the Switch here, thanks to iFixit and our friends over at Creative Electron. I always love just taking a sneak peek inside the device before we tear it down. You can see there's a lot going on inside the Switch. Would love to hear from the audience what components, what modules are you most interested in us discussing as we go through this teardown. I think from Jeremy, he was interested in the Joy-Cons, so we can talk about those later on. What jumps out to me, we can obviously see the battery here, an interesting thermal management system with the fan, looks like maybe a couple speakers, and then controllers over on the sides. So with that, I will hand it over to Chris to kick us off.
All right, let me share my screen.
Robert has a great reaction here too, that there's a fan inside. It is actually pretty impressive that in the small form factor they fit a fan.
Yeah, so this is the Nintendo Switch. Just to give you a quick overview, I've actually got my own Switch here. This is the original Switch, so you can see the difference between the, I think the outline of the display is much larger. It's kind of hard to see here, but there's like a much smaller amount of bezels around the outside, which goes from the, I think they had like a 6.2-inch display before to a 7.2-inch, which is a huge increase, and they really didn't change the size too much. But if you notice, I think the new Switch is just slightly wider, which is kind of interesting. So they had to make some changes on this new one. Also, I think if you look at the back side, they have this really large kickstand that is a new feature for them. It kind of reminiscent to me of the Microsoft Surface.
Yeah.
Where it's like the whole back is the kickstand, whereas before they had this like flimsy little piece of plastic that doesn't really stay up, and it was not
Those
honestly
kickstands
not
were
that
so
well
awful.
Yeah, I don't know if you had to replace any of those, Taylor.
I mean, yeah, they were actually really easy to replace, thankfully. They pop off almost by themselves.
Yeah. And I think you can see there's some differences in the speakers that they've made here. So there's some cutouts that are only on the front on this one, whereas I think on the older one, the cutouts are both on the front and on the back. So that's something that's a little bit new here. So yeah, let me go ahead and take off these Joy-Cons. We can come back to those later. And we'll see if we can open this up. So there's several screws on this. I actually kind of like exposed fasteners. I know it's kind of taboo in certain design areas, but I kind of like them. But one of the really interesting things is there's actually these, I don't know if you can see that, there's tri-wing screws here. And I think Tobias has some interesting comments about tri-wing screws. So when I take this apart, maybe Tobias, you can talk a little bit about that.
Yeah, I'll let you get a jump start there. This is a this is a never-ending debate that I've had on various designs. In particular, so tri-wings here, are they actually necessary from an engineering standpoint? And I'll explain a little bit why Apple used tri-wings. Or are they there, like a lot of people assume, are there to keep the customer out? People see, oh, this is an obscure screw head, it's probably to keep people out. Now, with Apple, a lot of people say that, especially looking at the internals, the tiny, tiny little screws, there actually is an engineering reason when you get down below about an M1.5 screw, the tiny, tiny screws, it's actually a more efficient design, both for manufacturing that screw head, as well as how much torque you can get. So with the tiny, tiny screws, it actually has an engineering reason. I would question in this design, I'd like to know from the audience too, do you think that they actually had an engineering reason, or do you think they're trying to keep people out? Looking at the size of those screws, that doesn't look like it's small enough to completely necessitate the tri-wing design. So I think that they were likely either following the trend that they saw with some of Apple screws, or intentionally trying to keep people out. I don't know, Taylor, do you guys see tri-wings very often in other designs?
I mean, they do mostly come from Apple products, and then we occasionally see them in something like this Switch. I am curious. I think the original Switch had tri-wing screws, so I'm wondering if maybe they were they were needed for the original Switch hardware design, and then they sort of just ended up as a carryover in the new design, even though they weren't necessary.
Right. Yeah, I mean, I think I'm more with Tobias. I think these are mostly to keep people out, since there are plenty of screw sizes that are can handle a Phillips or a different bit. But we're inside now, and you can kind of take a look. It's sorry, I got a ring light on, so it's a little shiny here, but there's this big metal shield, and we can immediately see a couple of antennas on the outside, as well as some big gaps here that they probably had to use for, I think, this hinge mechanism, which you can kind of see on the inside here. So the hinges take up a huge amount of space. These are pretty beefy hinges for this size of a product, and I think that's to get that really stiff. I just set that there, and it can it can kind of live there. But yeah, the antennas immediately, if you look at this, you can kind of see, I don't know if you can kind of see this, there's these really long cables here that go to the outside edge, and this is a really interesting design for me, that the connector kind of comes in almost at like a 270-degree turn. I don't know why they did that, but Tobias, maybe you have some ideas. But and then yeah, there's this just large shield with a lot of screws around that. So yeah, I can start to take off these shields, but Tobias, you want to go? Maybe we can take a closer look in the instrumental platform to see.
Yeah, let's dive in and talk about these antennas for a second. Sam brought up a great point about the original Switch design. There was a lot of connectivity issues between, I believe it was between the Joy-Con and the main unit. And let me see here, Chris, if you can stop sharing for a second, yeah. I can dive into a close-up. So here we're looking at the high-res teardown images in the instrumental app. And for anyone not familiar with instrumental, we provide a cloud-based AI platform that helps to prevent build delays, to accelerate product development, and to reduce quality escapes. So quick reminder, if you guys have programs that are coming up, you're worried about any of these things, please reach out and we'll find a way to help you. For today, we're really just using this platform as a slick user interface to look at some of these images for the teardowns. But looking at the antennas that Chris was highlighting here, so I believe this design is completely different from the original switch with these antennas. It looks like there's two here. I'm assuming one of these is Wi-Fi, one of these is Bluetooth. And I would speculate, and again, would love to hear from everyone here, why do you think that they put these antennas outside of this giant shield can here? My speculation is this likely is a redesign based on what Sam brought up with the connectivity issues in the past, and that they redesigned the antenna architecture. And one little side rant on antennas here, just based on my experience with antennas, it's a black box coming from my product design standpoint. Antenna teams, they try a lot of simulation. At the end of the day, you have to build it and get some empirical data to validate the design. And that's because it is so sensitive to minor variations, either in interference or even routing. And looking at, Chris was highlighting this little loop-de-loop, this 180-degree here. And this actually reminds me of a use case. One of the instrumental customers, they were building, it's kind of like a camera-based electronic device. And it was during one of their NPI builds, they had a chunk of units, I think 5% or so, that had significant antenna degradation, and nobody knew why. So they were kicking off this huge failure analysis effort to go do the normal DOEs, probably spend a couple of weeks. And they leveraged instrumental, they had antenna test data in the system, the functional data, and they leveraged that, and it correlated with images of this tiny little coax connector. And they found that if the coax was rotated just about 30 degrees off of where it was supposed to be nominally, that caused a degraded antenna performance.
No
Such
way.
a small
Wow.
little
That's
tweak.
fascinating. Yeah, that's really fascinating.
Small little tweak. No one would have ever noticed. The customers said that probably would have taken them weeks, if not months, to finally realize.
Seriously, though.
So that's my short rant on antennas. Extremely sensitive, extremely hard to predict, and that's kind of represented in this design here. They probably found something that worked and then just kind of locked it in.
Yeah, clung right to it.
Yeah, that's incredible, Tobias. I mean, one thing that I was surprised at is how long the cable lengths are without sort of like grounding points along the way. And maybe they didn't really need it here, but I know when I was designing Kindles, our antenna engineers were always like, it has to be grounded every 30 or 40 millimeters or so, otherwise it's you're losing signal integrity or something like this. So maybe there's an option for them to make their antennas a little better, or maybe they didn't need it. They had plenty of space. It is a pretty big
270-degree loop.
Yeah. That's maybe we needed to put a 270-degree loop in ours, and that would have made it better. But yeah,
all right,
go ahead.
Oh yeah, go ahead, Chris. What else?
I was gonna say there's some interesting other things in here that you can kind of see close up, and it might be better on here. But what are these like cutout holes for?
Yeah, there's some interesting designs on the shield here. Going back to the original design intent of the shield, thanks Chung Lin. I would agree that this is likely to shield some of the antenna signals from all the other electronic signals that's going on below. And I think we'll see as well that there's also some thermal management going on, that this helps as a heat spreader.
Definitely.
Yeah.
And we could talk about thermals in a second. I know there was a question from Robert that we'll get to in a second on how common these fans are. But a few interesting design decisions here. There's a little cutout for what we will soon see as a heat pipe. There are these cutouts in the shield can here, and a couple holes that don't look like they're actually needed for screws that I'd love to hear. We've got some hypotheses but would love to hear from the audience here. What do you guys think these cutouts are for? Chris, what do you think?
Yeah, I mean, well, having opened this and looked at this a little more closely, I think there's some vents which I thought were initially speaker vents at the bottom, but since I think Nintendo has talked about their sealed speakers as something new for this Switch, this is actually, they're just kind of air vents. Maybe that might be where holes for the air to go through, and they're kind of directing air to come in from the bottom and get sucked out maybe through that fan. So that's my guess as why they have that. Scott has a question.
That's real.
Scott's saying maybe they're PCB test points.
That's an interesting hypothesis here. It does look like there's 2 test points that they could want to leave open until the very end of the line or for debugging afterwards. I have seen that. I also thought maybe they're using the serial number here as the main unit serial number, and they want to leave that accessible throughout the whole line. Or it could be coincidence, but they have the ZIF connector here that they can still visually inspect. If they happen to be having issues, it's kind of nice to be able to have a final visual check there.
Yeah, have you seen other customers do that? I see like in the antenna area, there's also another ZIF connector there. Maybe they're just doing final visual inspections to make sure that nothing is out of place, so they can button it up before it goes out.
Yep, all good hypotheses here. And I'm also, Chris, maybe when we take off the shield here, I'm curious, these tapes down here, to me, it almost looks like a black tapped on tape, some type of prevention of shorting, but let's dive in and take a look.
Yeah.
So I'll flip it back to you.
All right, sounds good.
And maybe Taylor, I'd be curious to get your thoughts on Robert's question around how many of these portable gaming consoles actually have fans. Is this common? Obviously there's plenty of gaming that goes on some mobile devices, mobile phones that are not actively cooled. But have you seen, I know you guys have torn down other ones in the past. What have you seen with other mobile gaming systems?
So most of the mobile gaming systems that we have opened do have active cooling, and that's, again, usually a fan. For example, the upcoming Steam Deck, which Instrumental and iFixit will hopefully be tag teaming to tear down, that definitely has active cooling. Basically, I think it just comes down to a mobile device like a smartphone is intended for general use and not specifically gaming, where they're really trying to get every drop of power out of the processor, and so they don't necessarily need that active cooling. But a gaming focused system, even some of the gaming focused smartphones do have fans and active cooling. I think it's just a matter of, as soon as they try to get that extra power from the processor, they need to actively cool it. So generally, I would say, yeah, most of these portable ones do have active cooling.
Yeah, I think a lot of it's around the use case too. To Taylor's point, is the Switch is intended to be played for hours on end at maximum performance, whereas some of the other cell phones, sometimes you play for 15-20 minutes and it kind of peaks out. But go ahead, Chris.
Yeah, I was gonna say it kind of depends on like the chipset that they use. Like this, I think, is the NVIDIA Tegra, Tegra 1 or something like that. Whereas like this looks like a tablet, right? Essentially, but tablets kind of use ARM cores, which are much more efficient, and don't have quite as much power at the moment. And so they're really focused on the gaming and the processing power for all those triangles to make the images show up as crisp and as quickly as you like. I think Jerry had a question about the texture on the shield can. So I think you can see it's kind of dimpled every so often, and often in my experience, dimpling is there to help make this a little bit more stable. Otherwise, you can kind of get this oil canning effect where like the shield would go in and out. Tobias, I don't know what thoughts you have on that, but you don't. It's not like the sheet comes this way, because there are obviously these flat sections, but to help maintain some rigidity, you put like little points in that, and that's kind of formed in the tool itself.
Yeah, I think that's a great hypothesis, Chris. I don't actually know for sure, but you can definitely tell, because it's only on certain sections, flat planes, that it was likely introduced during that forming process. So it wasn't there in the flat panel state. So yeah, I would guess either to kind of affect the structural properties. Yeah, that's probably my best guess. But would love to hear anyone else who's dealt with shield cans, if you guys have experience on what the advantage of these dimples are.
Yeah, and it doesn't really cost that much in terms of Z height or something else to have a bunch of these little dimples in there. And once you etch the tool down to make this, it's pretty simple. So you can put any little pattern onto sheet metal. There was I think, Tobias, you wanted to point out what these black tapes were for. So as I rotate the device a little bit, you can kind of see, and I put this cover back on here, where these air vents are actually pretty transparent. So one of our suspicions and might be that it's just to prevent this shiny metal edge from showing up through that, because you have a black console, you have a black device, and you kind of looking at it from different angles, and all of a sudden you see this very shiny bright shield can inside. So I think they're just really taping this off to reduce the visual impact of what the shield looks like inside. I don't think there's any functional aspect to it, because it kind of covers these metal shields. So I'm taking this shield can off. I took up, let's see, 3, 6, 9 screws, and was able to kind of pry around these antenna cables. There's more loops on the back here just to get it in place. So a couple more 270-degree bends, or to get in place. Actually, it's like a 3/6, I don't know, whatever. So we can take that off. There's a big goop of thermal paste here. And yeah, I think this is, we're now looking at the major components inside. So sorry, this is still a little bit shiny. So on the right here, we have this giant battery, and I think when we were doing this in the pre-flight, Tobias has a beef with this upside down battery label. This is the front of the device. This is the top. Why is this battery label upside down?
It's killing me. It's killing me just a little bit inside.
But inside, I think it's a 4,300 milliamp hour battery, so works out to about 16 watts at 3.7 volts. And I think, Taylor, is this the same battery that was on the original Switch?
Yeah, this is the same cell.
So that's good news for repairability, right? You don't have to have different cells for different upgrades.
Absolutely, and saves them a bunch of money, I'm sure.
Yeah. What else do we got in here? I think, looks like the heat pipe and the fan are up there. There's something big and probably power hungry underneath that heat pipe. You can see there's a separate board over here. But yeah, I mean, I think, I don't know, Tobias, is this better to go back and look at instrumental now that we're in here?
Yeah, let's look at a few of the details.
Yeah.
Let me pull up. And now we can really zoom in. So first thing I noticed, they packed a lot of stuff in here. So I'm impressed overall with just the layout. They might have done some optimizing from the first generation to the second. And yeah, this thermal management is really interesting. They've got the heat pipe, the fan, as well as thermal paste, which connects with the shield can. And a lot of connectors that we can talk about in a second. And they have this separate board over here with what looks like maybe a little black piece of foam here. This is kind of interesting. We've got a few different theories here, but let's hear from the audience on this black foam that appears to be on the back of this PCB. Any thoughts on the design intent for this black foam?
Chris, is that foam where the board-to-board connector is on that?
I think you're right, Wayne. We can maybe take a look at the other side, but from this side, it's kind of unclear how this board is connected. But I think Taylor, having taken this apart before, maybe knows that there
sorry
is a
to spoil
single...
it. That's just crucial information for your guesses.
Yeah, that's a good thought. We'll pop that off in the next step and see this little one here. This is always a fun one that some people either have great experience or horrible experience with. Anyone know what this tiny little sticker is right here with the little red dots? Oh yeah, we've got Robert snuck in the answer first. Water indicator, water or humidity. So yes, this is often used sometimes during development to see if there's water ingress, also for device returns, warranties, whether it actually had water damage. And so let's talk about thermals for a second here. When I see this giant glob, and clearly there's a lot of design intent focused around the thermal management, it reminds me of the drone, the DJI that we actually did last time. And we actually have those images right here. Again, for anyone that's interested in getting access to this whole library, you can see in one spot here, we've got all the different devices that we've torn down. We have the full high resolution image library. So if you want access, we can hook you up, email communications@Instrumental and tell them that Tobias sent you, and then we'll get you some access to this image database. And the DJI just had an insane amount of thermal management. It was on almost every PCB. They had this thermal paste. And I've had many good and bad experiences with thermal paste. I know multiple of our customers have struggled with thermal issues, both in reliability tests and in the field. And then you go back to the original image and you realize that the pattern had shifted a little bit. Now, it wasn't enough to trigger whatever tests that they had in place. These things are difficult to test for 100%. There was just a little bit of shift in the process, not enough thermal paste, causes latent issues way down the line. So thermal management, that goes in the category as well as really tricky to detect process shifts. All right, let's see what else. I know we have some interest in the Joy-Cons, which we can get to later on. Let us know if you see anything else jump out at you that you want to spend a minute on. We'll dive into the thermal system here, and we can take some of that stuff off. One other note that I'm interested in, they have a lot of different types of connectors here. So they have these ZIF connectors. They have kind of the standard Molex jumpers here. They have, this one is actually really interesting. This one threw me off when we were taking it apart. At first I thought, this is just a standard pin header that I'm gonna unplug sideways, but that did not work. Chris, what was your experience taking this guy off?
I was trying to tug it out. I was trying to pull it back, and I was like, how do they design this? Because there's no room to pull it back. And then I figured it out. But it's it's a really clever solution for this very short amount of space that they have for their cable routing. This actually reminds me of my current job. We're doing cable routing as well, and I'm like, oh, I have so much room in a tractor to do this, but the wires are actually about 1.5 inches thick, and so the bend radius is like 6 inches. So I have the same problem, just scaled up. If I zoom out on this CAD, it's like the same problem, which is really fascinating. I thought I got away from this kind of challenge of fitting things into small spaces, but going to it's mechanical principles apply everywhere.
All right, so I think of the next step here. Chris,
Yeah.
have you already popped this one out, or do you
I
want to?
haven't yet. We can show that.
Yeah, it's an interesting connector type. I haven't run across it before. Would be interested to hear from the audience if you guys have seen this specific connector. It's kind of a hybrid of two different types.
So I think this just kind of lifts up, actually. So it pops up, which is really cool. So it's just you get the bend and you get it close, and then you just snap it in, or you pop it back up. So
I think the only place I've seen that style of connector is in laptops occasionally. Laptops, I think, use a similar connector to that.
I can see that. I think that makes sense. Where they have probably low Z height, but then maybe they have a little bit more room, and then you don't want to be. I think those laptop batteries tend to have a lot more cables too, so it's kind of harder to wiggle them in place.
Yeah.
So
I could see it. Yeah, and typically in the design connector space, this is what I've seen is when you're really constrained in Z height, ZIF connectors, which we're seeing here, are very low profile. The board-to-board connectors are the best for conserving XY space when you have a little more Z. This one, my best guess is they wanted to conserve Z, but it's a battery connector, so it needs those thicker wires. So they're not putting that on a ZIF ribbon cable or a flex cable. So it's kind of that intersection of they need the low profile and Z, but they're constrained by having these larger wires. Looks like we have a few people that have seen them. Chung Lin has seen them on some cameras, a couple other places. We have some questions here from Russ on if these have been washed post-assembly. Are they no clean? Russ, I'm not sure if you can clarify what specifically you're talking about, the cleaning process. Is this like on the full device, the finished good, some type of post cleaning, or on specific components internally? You're asking about, are they nano coated? I'm assuming nano coating. I have seen nano coating on PCBs for waterproofing. Instrumental actually worked with P2I. It's a company that does waterproof nano coating over components. Oh, yeah. These do not look to be nano coated. Chris or Taylor, I don't know if you guys have seen any actual PCB coating, but to me that looks just like a standard PCB.
Yeah, I've never seen a coating on a switch PCB.
Yeah, I don't see it here either, and I think it kind of depends on how this is used. Like an iPhone or a mobile phone or something, you expect it to be maybe dropped and taken around near the pool, something like that. But once in gaming, you're kind of sitting on the couch, you're by the TV. There's less risk, and they probably are pretty splash proof. So if you spill your soda on it or something, it's probably not going to be too bad. But it doesn't look like they have too much. But if you do dunk it, they have that little water protection detection thing to make sure that you're not operating it and just trying to return it for a replacement. But yeah, so I did take off this one. It is, as Taylor mentioned, a single ZIF connector, which is pretty interesting, or a single board-to-board connector, which is pretty interesting because this is kind of a wide rocking, a wide cantilever, as we would call it, where if you press down on one side, it could lift up. So that's probably what that foam piece is for, to really balance that out. So I'm taking this part off. So I got the thermal management system off, and it's creating a mess on my my iFixit magnetic pad, but I'll have to replace some thermal paste later. But it comes to a little heat sink or like a lots of little fins here to really distribute that heat afterwards. So that's pretty interesting. And it goes on top of this shield, which if I'm able to take this off, I'm kind of mangling it now.
Yeah, those shields are really tough to pull off.
Yeah, there it goes.
There's a lot of heat distribution here, though. They have the APU and then that small shield, and then they have the heat sink, and then again the big shield. So like a lot of different places for this heat to get out.
I don't know why this is. I think I bent this, but that's okay. I can just take that part off.
We got a good question from Scott on the thermal management. Are they all pastes or are any of them pads? And I think most of them are pastes. That one on top of the shield can, that's a paste, right, Chris?
Yes, this is a paste. I don't know why this is. So there's a paste. You can see it's leaving marks on my pad over here. There's a paste on the top and a paste on the bottom, and then we'll see shortly what's underneath here as well. There's a paste. I can see it. There's a paste between the main chip as well. Yeah. So paste to paste to paste. That's kind of how we're going here. I think there's like a one dab in here. It's giving me problems.
I have seen, I think there was one pad, and again, Taylor, you probably have some comments on pads versus pastes in terms of repairability. I know reworkability of pads is a lot easier. It's going to be a lot less messy to swap out a pad than a paste. But again, there's some design and efficiency trade-offs in those as well. What have you guys seen in terms of repairability of this thermal?
In the Switch specifically, thankfully that Tegra, the second version of the Tegra processor that they're using here is pretty efficient thermally, and so the console is forgiving with your thermal paste reapplication. We often, when we reassemble our devices, since they're not being used, we just reuse the thermal paste. And even that does okay. Generally, pads are a lot better to reuse. I mean, like I wouldn't ever advise reusing thermal paste, but a thermal pad you could get away with reusing. And I mean, personally, I think the inefficiencies of a pad usually are not worth the reusability, because thermal paste, it can be intimidating, but really all you need to do is put a little dollop on there, and it's okay. You just need to make sure you have the right paste and whatever. So if the manufacturers would just say, hey, here's the paste we used, if you want to repair it, then that would be great. But since some of them don't, that can kind of be annoying. So it's a bunch of trade-offs, like always.
When you guys repair or get people that ask about repair, how long do you think the paste kind of lasts? Is it like several years? Is it like a year or two? What is when are you seeing that people are doing that mostly?
It depends on the application and how sealed the paste is, or like how enclosed it is. If you open a device, that immediately sort of takes away from the lifespan of the paste. But generally, paste will last you, I think, 4 or 5 years, and even then, it will still be okay. I know, like some of the PlayStations, I think the PS4s, like it was just a couple years ago, or maybe 1 year ago, that people started to like pop up on forums and say, hey, I replaced my thermal paste and wow, everything's so much better. Um, so yeah, that was well into the life cycle of that console. So I think usually that's something that you don't really need to worry about.
Okay. So I've taken out a bunch of screws, and I think I've taken off a bunch of connectors as well. Looks like they have a connector for this fan, a connector for this. There's some buttons at the top here, a connector for I think these are the switch Joy-Cons on either side, and then the battery connector, and I think there are two more speaker connectors, and I've removed some screws for the USB-C connector as well. So there's a lot of, as Tobias mentioned, a lot of things going on here, a lot of different connections and different connection points, which makes this a really fascinating board to look at and a teardown, because there's just a lot of stuff in here. Let me just kind of try to.
I'm excited to take a look at the speaker module design as well. I think that was one of the deltas from the original Switch. Looking at the speakers in the bottom left and bottom right.
Yeah.
Taylor, did you notice that when you were comparing those?
Yeah, definitely. And there was actually a really long article with one of the product designers where they talked in depth about how they redesigned the speakers. And the old speakers they emitted sound from both directions, and these new ones are only front firing, which is sort of the more common application. So I'm sure you guys know all about that.
So I got this out. Maybe you want to take a closer look on instrumental, because otherwise it's going to be a little bit hard to get into that.
Let's look at the speakers here. One more question from Scott before we dive in. Maybe you can look while we're looking at the speakers. That heat pipe there, how is it bonded to the fin structure that's up there by the fan? Looks like it's permanently bonded. So
Yeah,
I think we're looking at.
I think it is
right up
permanently
here.
bonded. I don't know how it might be soldered on. I know copper tends to be pretty difficult to attach to things, so yeah, I think they do some special things to connect it to the plating on this heat sink as well, on the fins.
You could try to rip it off, see what happens. Sacrificial heat pipe. Yeah, my bet, maybe I don't see any solder overflow around the outside. So either a very well controlled solder or some type of thermally conductive adhesive that's designed to stick to this copper.
Yeah, I will say that the way this is attached to the frame itself, there is like a piece of copper tape that has adhesive on both sides. So just at the bottom side of the heat sink is touching off there. But I don't know if I can take this apart at the moment.
All right, let's keep moving here, because we still have some fun stuff to look at. And again, in this instrumental platform, we're looking at a lot of great visual data today, but the instrumental platform, it helps to aggregate all product data. So it gets extremely powerful when you have the images and the functional test data. I mentioned before the failure analysis. That's really what resonates with me, as I spent years doing failure analysis. We've had a lot of recent pull from larger devices as well. I know we're looking at a lot of small devices, but we're working with customers in like the EV space, solar, autonomous vehicles, and a lot of their drive is around keeping yields high, reducing quality escapes. A lot of these are, mission critical, where even one escape can be a huge deal. So again, if you're interested in learning more about some of the expanded capabilities, our team has a lot of exciting product releases coming out around failure analysis and correlations. And that, again, the speakers here reminded me of that, because this is another area, along with antennas and thermal paste, that's just so tricky to control the process on. So looking at Looks like we have this housing here that we can talk about the different coatings. Looks like there's some interesting, you can see this is just the raw frame, but here there's some black paint, and then it kind of transitions to glossy right on the outside. But this speaker design, as Taylor was mentioning, it looks completely enclosed and it's firing out the front. So I think actually if we go all the way back to the front, oh, here's the front of the device. You can actually see right here in the housing, there are these small slits. That's actually where it's firing. And so there's a plastic cap on top here. And when we remove that, here you can see the speaker module, which is completely sealed by this adhesive. And what's really interesting, they snuck this wire out with what looks like, again, to keep it completely sealed, these two little rubber stoppers, which I can only imagine how difficult that would be. That's a manual process. They're placing those in there. And you can even see here, when I was taking these apart, one of them popped loose here and I wasn't able to completely put it back into place.
I'm impressed that you were even able to get it in place that much. Those are incredibly fiddly.
And these are the things as well, where if that falls out, these are not things that functional tests are guaranteed to catch, because it might affect some overall speaker output, or there's some rub and buzz that happens after some reliability events. And these are the types of things that our customers see all the time, and that we're able to help catch early on, so you're not spending weeks hunting down what the root cause is. And we have these pads on top. I don't think they're thermal pads. Chris, what do you think these pads are for in the speaker?
I think they're probably just noise isolating, just to kind of touch off on the other part. They're kind of dampers, I guess, because speakers just vibrate a bunch. So it kind of just presses it against the rest of the frame there underneath. That's my guess for that.
Yeah, you can see little indentations there where they make contact with the plastic housing.
Yep. And one more thing that just bugs me. I'm very curious. So let me hear the ideas here. This is a small plastic part that is screwed into the frame here, small black plastic, and I just can't figure out what the purpose of this part is. So if anyone has an idea of what the design intent of this part is, I would love to know.
For orientation, is that where is that on the top of the console? Is that near the game card reader?
Top right. Yes, by the memory card reader.
Oh, the memory card reader. Okay.
Yeah, that is by the memory card reader. To me, it looks like one of those legacy design features that maybe was in the original Switch, and they didn't want to radically change the design of either the housing or the PCB, but they needed a hard Z stack, and so they just added in a little plastic spacer so that they didn't have to change, the mold design of this frame. That's what it looks like to me.
Yeah, I think I was looking back actually at Taylor at your guys' original Switch design. I think one of the antennas used to be up there, and so that might be a space where it had an antenna and it was on a carrier, and that's what bolted down. And then they just replaced it and didn't think about they maybe had some rel problems where the card carrier was failing, so they just, let's put a spacer in. So we can do that.
We do have a question from Stephen Deeds, who asks if the housing is plastic.
Ah, that's a good question. So if you look, there's this very clear indication of what the material is. It's AZ91D. I'm pretty familiar with this because at Amazon we use this a lot. It's actually a cast magnesium frame. And so anytime you see this kind of dull gray color frame inside of a consumer electronic part, it's probably magnesium. And it gets that way because it's got to be passivated. Otherwise, you get that magnesium. If you did experiments in chemistry, burns very brightly, so you want to make sure that it doesn't corrode. So you actually put it through some chemical processes, and it comes out this color.
Nice. And why? We want to share a little bit about why they chose, or why we think they chose magnesium over, let's say, an aluminum frame.
Yeah, I think magnesium casts very well, and I think you get a lot of a long life out of it. It's also pretty lightweight for the amount of strength that you get, and because this product has so much stuff in it, the display, this giant battery, they probably wanted to keep the weight down because it's a relatively portable device. And also, you can create all these walls and different shapes. You can tap different holes, put it on different surfaces. So I think it fit what they needed to do pretty well, and it's often found in the middle frame of a lot of consumer products, laptops, and things like that. Just because it's pretty flexible. Some of the downsides are you get maybe some warpage, you get a little bit of your flatness tolerances aren't as good as those Apple products that are precision machined. But it's a very functional and very low cost way to get a stiff part in there.
Great. Thanks for sharing. All right, we have just a few minutes left. So any final questions, anything you guys want us to deep dive on here? We can look at, again, we can talk more about the painting, the different coatings that we have on the frame. We could take a quick peek at the controller, or we could dive deeper into some of the PCBs here. So let us know. Last questions. I do see, what stands out to me here is this little pocket here that's painted black, which is kind of interesting, with what looks like conductive foam, which is likely grounding some of the other components to this frame here. And also a little black paint down here on the inside, which is interesting. I think those are areas where on the back, when you pull up the hinge, you actually look behind the hinge. Yep, right there. If you look behind the hinge, you see into that pocket.
Yep.
So those are all little cosmetic details.
And those conductive foams are touching off on the metallic part of the hinge as well. So there's some, just to make sure those aren't floating ground, because that goes right next to the Joy-Cons, I think, which have their own maybe some. I guess once they're connected, it's fine, but they might have some antenna performance issues there as well.
All right, we can spend 2 minutes on the controller here, but I know we're right at the top of the hour. So if anyone needs to drop off now, 2 important reminders. One, thank you for joining. Yes. Thank you for the repeat attendees as well as the newcomers. If you want access to these images, email over communications@instrumental. And our Build Better events. This is the real deal. March 3rd, half-day virtual event where we're gonna discuss trends in the industry, best practices. We posted the link in the chat here, and would love it when you sign up. Put in a plug for Teardowns, and if we get enough feedback in that sign up about what we want to tear down, then we will convince the Instrumental team that we need to do a live teardown during that event. So Build Better, March 3rd, and again, the survey at the end, which is super helpful to help us improve for next time. So let's take a quick peek at the controller. I don't know, Chris, do you have the screws out so we can take a little sneak peek inside, or do you want me to pull it up?
Okay, just took the screws up, but there's some snaps in here as well. Maybe just go ahead and pull it up on yours.
Yeah, those controllers are really fiddly, not great for disassembling in a hurry.
So here's the Joy-Con, and I just popped it open and left everything connected. but they do pack a good amount of complexity in here. So it looks like you have the battery in each one, the PCB connected with the ZIF to what is likely the interface PCB.
Yep.
And this module down here, I believe that's the vibe motor, because I think the Joy-Cons do have vibe.
Mm-hmm.
They have the vibe motor. And then we've got the trigger. We can't actually see the Joy-Con from this side. I think we'd have to dig a layer deeper down here.
Yeah, you remove the cell there, and underneath there are a couple screws, and after that whole mid plastic layer comes up, and then you can access the Joy-Con or the joystick assembly.
Nice. All right.
So not too complicated to pull out that little guy.
Yeah. Have you guys seen many repairs on the Joy-Cons, Taylor?
Many repairs. In 2020, when the pandemic was starting, we saw a huge spike in replacement Joy-Con orders because people were just at home trying to play Animal Crossing and their Joy-Cons were drifting. So yeah.
Maybe they got more use than expected on the reliability testing. We didn't get to it at this time, but I would be curious to know what reliability tests these went through. How many millions of cycles on the Joy-Con?
Yeah.
Are they predicting as lifetime? People get angry, they throw the Joy-Cons. Lots of various corner cases. So, all right. I think with that's a wrap. So thank you so much, Chris, and thank you, Taylor, for joining us today.
Of course.
Thank you all in the audience for participating, and we'll see you next time on Change Notice and at Build Better.
All right. Take care.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.